finding the inverse of the cotangent, secant, and the cosecant. So we look at first one. Finding the secant inverse, the easier approach would be use the inverse of the cosine. And then we simply to swap the inside term, which is the inside term x. The reciprocal of the x term will be 1 over x. So if you are looking for secant inverse of the x, you just rewrite it into the cosine inverse and the reciprocal of the inside term. Same as the cosecant inverse. We use the sine inverse and take the reciprocal of the inside. Now, with the cosine function, the inverse of the cosine function of the range has from 0 up to pi over 2, and then from pi over 2 go to the negative pi. So eventually, we just need to know by looking at the graph, or you just need to know they are the outside of the negative pi over 2 and the pi over 2. But eventually, when we find in the secant inverse, you simply to use the cosine inverse and take the reciprocal of the inside, and that's it. With the cosecant, we find the inverse of the sine and take the reciprocal of the inside. So the range of the cosecant inside function, they are considering with the 0 up to negative pi over 2, union from pi over 2 up to 0. Now, this one, cotangent inverse. Cotangent inverse is a reciprocal of the tangent inverse. So finding the cotangent inverse, easier way to do it would be finding the tangent inverse and take the reciprocal of the inside. If your x greater than 0, when your x value is at 0, when you have the tangent inverse, x is not greater than 0, which is it comes with a negative angle. Once we solve it, we have to add 180 degrees to find the actual angle. The reason why we have to add 180 because your cotangent has the inverse of a cotangent has a range is between 0 and the pi. So with between 0 and the pi, we will be able to find the inverse of a cotangent. So when you find a degree, for example, here, this is a negative 40 degrees, for example. This is on the quadrant 4. Eventually, on the quadrant 4, tangent will not be able to find the inverse. So we know only inverse will happen with the cotangent, either quadrant 1 or quadrant 2. So which is they only between this interval. So that's why you have to add 180 degrees so that you can find the reference angle on the quadrant 2. So that will be the reference angle. So with the cotangent inverse, you need to pay a little bit attention. But with the secant and cosecant inverse, you just use this way to solve it. Now we take a look at the question. Finding the inverse of the cosecant negative 2 over root 3. So we just rewrite it into the sine inverse, and then you swap the inside term. Negative sign never be changed. Whatever negative sign, if there is a negative sign, it's there. You only swap the numerator and the denominator. So once I swap, it turns to root 3 over 2. Now, if you consider the sine inverse function, we only deal with the quadrant 1 and quadrant 4. Negative root 3 over 4, that indicates is on quadrant 4. So when you have the negative root 3 over 2 on quadrant 4 would be negative pi over 3. So your arc cosecant would be negative pi over 3. Now finding the arc, which is the inverse of the secant, we use the cosine inverse, and then we upside down the inside. So we have the 3 over 2 root 3. rationalize the root 3, we multiply with the root 3 on the top and the bottom. So it will tend to cosine inverse negative 3 root 3 over 2 multiply 3. Because you have the double square root 3, it turns to an integer 3. Now this 3 and 3 cancel out. So it will turn to the cosine inverse negative root 3 over 2. Cosine inverse only happen between 0 and a pi. Between 0 and a pi. So when you have cosine is negative value, which is it happened on quadrant 2. So on quadrant 2, your cosine inverse, you're getting the negative root 3 over 2. That would be at 5 pi over 6, which is that happened at 150 degree. Cotangent inverse, negative root 3 over 3. So we use the tangent inverse, upside down 3 over root 3. Rationalize root 3. So we get a tangent inverse, negative 3 root 3 over 3. So they cancel out. So you have the tangent inverse negative root 3. Now tangent inverse negative root 3, if you look at the chart, you will know the angle is happen on quadrant 4 because your tangent we only take the pi over 2 and the negative pi over 2, just like the sine here. So finding the tangent equal negative root 3, tangent is getting from sine divided by cosine. So only chance you can get a negative root 3 would be negative pi over 3. So we write down the negative pi over 3 when you have the tangent inverse with the negative pi over 3. However, we just mentioned earlier, your inverse of the cotangent only happen between 0 and a pi. So now your negative pi over 3 is on quadrant 4. Right, this is on quadrant 4. And here. So this is negative pi over 3, which is negative 60 degree. Inverse of the cotangent only happen between 0 and a pi. So in order to put it into the right interval, we have to use the reference angle idea to calculate the negative pi over 3. So on the other direction, that would be the 2 pi distance or location. So when we add the 2 pi into it, we will get a 5 pi over 3. So eventually, when you have the cotangent inverse with a negative root 3 over 3, this is equal 5 pi over 3. My bad. This is not a 5 pi over 3. We just add a pi. My bad. Okay, so here, when we have negative pi over 3 plus pi, so we will get 2 pi over 3. So this is a 120 degree. There you go. So sorry, here we just add a pi, not a 2 pi. 2 pi is one fully rotation. So we just add a pi into it. So here we get a 2 pi over 3. So your cotangent inverse with a negative root 3 over 3, eventually this is equal 120 degree on quadrant 2. So you begin with using the tangent inverse upside down the inside number. From there, you find the angle on quadrant 4. And because the cotangent inverse only happen between 0 and a pi, so we add a pi into it. When they combine together, you get a 2 pi over 3. And that will be the 120 degree. The rest of the question, they use a calculator to solve it. When we have the test, I will not give you a question like that. So everything everything must have that exact value, you can go back to reflect to find the corresponding degree. So this is the way you define the inverse function of the plane function, which is your original 6-tree function. When you find an inverse, you need to consider the range of the inverse function, which is they are all getting from the domain of the plane function. When we have the 6.2, we will solve a trig equation, and we use the inverse of each function to find the angle. But we will do a little bit different from the work here. Alright, eventually that part is easier. So we will do that on Wednesday.